Time Domain Integration, TDI, and line scan. What's the difference between these two technologies and when should you use them? Today we'll find out. So line scan is a type of X-ray sensor that has one column and several rows. Some line scanners have maybe 2, 3 columns, but the whole idea is that it's a very skinny X-ray sensor. And images are formed when you move the sample over the line scanner. So here's our line scanner. In this case, we have one long column and a bunch of rows, right? Each one of those squares is a pixel. And here, this representation, we have an X-ray source that's shining X-ray photons shining on this line scanner right here. And as we move the sample, the line scanner is sampled at several times a second. Sometimes this can be in kilohertz, 12,000 samples a second or 24,000 samples a second. So this is being scanned and then slicing through the sample as the sample travels on top of the line scanner. Now, there's a special type of line scanner called TDI, which is time delay integration. And a lot of people ask us, what's the difference between line scanner and a TDI? A TDI is a type of line scan. It's a special type because instead of having just one column with a bunch of rows or a bunch of pixels, the TDI has several columns, 150 columns, right? Several columns with a special characteristic. Instead of scanning and presenting the image one slice at a time, the TDI scans the sample in the first row, and then that information is moved to the next column, and then to the next column, and then so forth, all the way to the last column. So you can imagine that as the sample moves on top of the sensor, this information here in the beginning of the sample gets moved and jump from little column to column, all the way to the last column, and then the image is formed when this piece is then scanned and sliced through to make an image. Now, TDI is brilliant for situations where you don't have a lot of luminosity or very low light or low X-ray situations, very dense samples, for example, where you want an integration line by line of your data all the way to the last column for the image to be created. It's also really fast, right? Because now you can scan through this column very fast. You have to be careful, correctly sync the speed of the sample with the speed of this moving of the columns, because you can imagine if you are shifting, right, and integrating from column to column at a different speed at which your sample is moving, it's going to be a total mess. It's going to get super blurry and it's not going to work out. So that's why in TDI applications it's crucial to have some type of indexation, and this can be done with different devices that will code the speed of the sample, and if the sample speed changes, it will automatically change the frequency at which information is moving from column to column. So this is the main difference why you use a TDI instead of a line scan. Another big difference before I finish here, TDI is way more expensive than a simple line scan. So if you have an application, then you need speed and higher luminosity and higher resolution, TDI is the way to go. For most applications out there, they use a line scan like the airport, food inspection, in some ADT applications, a line scan is what's used. So I hope you enjoyed the video, learned something, and don't forget to subscribe. Thanks for watching.